So welcome in this session. This session, we are going to do a problem on how to find linear combination of a vector in terms of other vectors. So the problem is, if possible, write the vector W as a linear combination of vectors in the set S given by these three vectors. Now to solve this, you have to remember the definition of a linear combination of a vector in terms of other vectors. So we call this V1, call this vector V2, call this vector V3. So the problem would be, we need to find scalars C1, C2, and C3 such that this vector W can be written as C1 V1 plus C2 V2 plus C3 V3. This is the definition of a linear combination. So putting in the vectors, so W is 1 minus 2, 2. So 1 minus 2, 2 is equals to C1. V1 is 1, 2, 3. C2, V2 is 0, 1, 2. C3, vector V3 is negative 1, 0, 1. And then we simplify the right-hand side. So we have 1 minus 2, 2 is equals to C1, 2C1, 3C1 plus 0C2, C2, and then 2C2 plus minus C3, 0C3, and then C3. Remember, if you have a scalar, you just multiply by every element of the vector. So we get a sum on the right-hand side. So 1 minus 2, 2 would be C1 plus 0C2 plus minus C3, 2C1 plus C2 plus 0C3, and then 3C1 plus 2C2 plus C3. And for this equality to make sense, then the first element to the left should be the same as first element to the right. Second to the left should be the same as second to the right. Third to the left should be the same as third to the right. So this implies C1 plus 0C2 minus C3 equals to 1. 2C1 plus C2 plus 0C3 should give us minus 2. 3C1 plus 2C2 plus C3 should give us positive 2. So this is a system that we get from that vector equation. So the equation now reduces to solving a system of three linear equations in three unknowns. So to solve this one, we write the augmented matrix of the system, which is 1, 0, minus 1, 1, 2, 1, 0, minus 2, 3, 2, 1, positive 2. So this is what we call the augmented matrix of the system. Now, from this augmented matrix, let's use Gaussian elimination. Solve it. Gaussian elimination simply means that we need to write the system of this matrix in rational form. and then solve by back substitution. So I'll rewrite the augmented matrix 1, 0, minus 1, 1, 2, 1, 0, minus 2, 3, 2, 1, positive 2. And then I'll say row 1, I keep it to be row 1. Row 2, I'll say row 2 plus negative 2 row 1. Row 3 will be row 3 plus negative 3 row 1. What's making me to do that is because this position should be 0, this also must be 0. So by doing that, we'll have, so this is the leading one in the first row. So we'll have 1, 0, negative 1, 1, 2 plus minus 2 times 1 is 0. 1 plus minus 2 times 0 is 1. 0 plus minus 2 times minus 1. So 0 plus minus 2 times minus 1 is positive 2. So this will be 2. And minus 2 plus minus 2 times 1. So minus 2. So this will be minus 4. 3 plus minus 3 times 1 is 0. 2 plus minus 3 times 0 is 2. 1 plus minus 3 times minus 1 is, this will be 3. So it will be 4. So this will be 4. 2 plus minus 3 times this element is 1. 2 minus 3 is minus 1. Now with that step, next thing now I want to still row 1 to be row 1. So this okay. And this also should be the case. So row 2, I make it to be just row 2. And then row 3 will be row 3. Because I expect this to be 0, I'll say plus minus 2 row 2. Now that one will lead us to one, 0, negative 1, and then 1. Here we'll have 0, 1, 2, minus 4, 0. This will be 0, 4 plus minus 2 times 2. This is same as 4 minus 4, which is 0. And then minus 1 plus minus 2 times, this will give me minus, this element here is minus 4. Minus 2 times minus 4 is 8. 8 minus 1 is 7. So I get here 7. Now, because I'm getting a non-zero value in the third row, yet I have all the zeros on this side. So this is 2, and this minus 4. Now this, from this, it implies that I have the system C1 plus 0 C2 minus C3 equals to 1. And then C2 plus, or say 0 C1 plus C2 plus 2 C3 equals minus 4. And here I have 0 C1 plus 0C2 plus 0C3 equals to 7. You see, it's not possible. This is absurd. This is absurd. Since you can't say 0 is not the same as 7, but that's the implication of this last equation. So therefore, since the third row let me call this one star of star doesn't make sense, or this same way of saying is false. The system let's give this one a name. So let's call it system even alpha. The system alpha is inconsistent. So when you say inconsistent, to mean that the system doesn't have a solution, does not have a solution. Hence, W cannot be written as a linear combination, be written as a linear combination of vectors in S. W cannot be written as a linear combination of vectors in S. Vectors in that set S. So that is the conclusion, because the system is inconsistent. So you can't find C1, C2, and C3 satisfying the condition given this definition here. So that's how we solve that. Thank you.